In this video, we look at graphical techniques for doing limit problems from section 1.8. Okay, and what we're seeing in this problem is the graph given to you of two functions, one for f of x, and you're also given the graph of a function g of x. Okay, and notice that please note that we don't know any formulas for these functions, and that is not necessary to know these formulas. So don't spend any time trying to find what formulas these are or trying to graph them on your calculators. You have everything you need in these pictures right here to answer the questions. Okay? So let's get into this problem. Let's do part A here. Okay? We've been asked to find the limit of the function f plus the function g. Okay? It turns out that a property of limits is that if you have the limit as x goes to 1 from the left of a function f plus a function g, that you can turn this into two limit problems. The limit as x goes to 1 from the left of f of x. Just do that problem first. Do a second problem where you compute the limit as x goes to 1 from the left of g of x. And then when you're done with those two steps, the third step is just to add those two answers together. Okay? So let's first deal with problem number 1. Let's see if we can use this graph and this graph right here, graph of f, to answer what is the limit as x goes to 1 from the left. Okay. Remember how we did this in the table of values. We always chose a delta x to be, say, 0.5. Okay? And then we chose a smaller delta x to be 0.1. And then we chose a smaller delta x to be 0.01. Okay? And every time we picked a delta x, we found a minus delta x, right, to find, say, a value of x is equal to 0.5, and then you evaluated the function at 0.5, and you figured out what that number was. So we can see here on the graphical techniques, there is the function at around 0.5. According to the graph, it's approximately 2. Okay? Now go to the problem where you take a smaller delta x. Delta x is about, say, 0.1. Okay? That means this is our value of x, a little bit 0.1 steps to the left of 1. Read that up on the graph, and you can see that that value is somewhere around the function at, say, like 0.9 is somewhere in the vicinity of, say, 2.5. Okay? And now keep going with the limit process. Get closer and closer to x equals 1, and you can see that every time we get closer and closer, we're getting closer to this point. And according to the graph here, we're seeing that this point, which is an open circle, means that the graph is not defined at 1, but it looks like we're getting closer and closer to this value 3. Okay? So the value of the function from the left is equal to 3. Okay? And please note that that did not depend, this is a very important point here, note that the function evaluated at 1 does not exist. Okay? This function, there's an open circle. This function is not defined. Okay? And yet the limit still did exist. The limit, as we got closer and closer to 1, the function was getting closer and closer to 3. Okay? So now we need to go to the other graph. We've answered step 1. Let's go to step 2. The limit as x goes to 1 from the left of this function. Okay? Let's do that process graphically. Here's a value of x to the left of 1. and its value is a little bit less than 6. Okay, let's get a little closer to 1. Okay, and look at the value of the function. Okay, and we're more or less than 6, so maybe around, yeah, like 5.5 or something. And the closer and closer we get to 1, it looks like we're getting closer and closer to this value 5. Okay, and again, note that g of 1 does not exist. So the limit from the left can exist, but the function does not have to exist. Okay, and now we can put these two steps together. The limit of the function f plus g as x goes to 1 from the left is equal to 8. Okay, so that would be the answer to this problem. All right. Let's try another one. Okay. All right. Let's take a look at number B. Okay. Properties of limits will say that the limit as x goes to 1 from the right of f of x plus 2 times g of x. Okay. We can turn this into the limit as x goes to 1 from the right of the function f of x. Do that problem first. Then do a second problem, the limit as x goes to 1 from the right of 2g of x. That would be our second problem. Okay, and then third step would be to add the two together. What's slightly new to this problem is the 2g of x, 2 times the graph of g of x. I don't want to have to draw the graph of twice the function g of x, so what we're going to do instead is problem 2 splits into a part A and then a part B. And what that means is that you can do the limit as x goes to 1 from the right of g of x, and then the second part would be to multiply the answer by 2. So with limits, the 2 comes out in front of the limit. Okay, that's a property of the limit. And so we just need to compute the limit of g of x first and then multiply the answer by 2. Okay, so let's go ahead and do part 1 first. We need to look at the function f of x as x goes to 1 from the right. So we're getting closer and closer to 1 from the right, and we're looking at what the values of y are getting closer and closer to. And we can see that even though the function f of 1 does not exist, we can see that the limit as x goes to 1 from the right of this function is getting closer and closer to 4. Okay. Part 2a, we need to compute the limit as x goes to 1 from the right of g of x. And as we're getting closer and closer to 1 from the right of g of x, this function is getting closer and closer to 1. Okay. And therefore, part 3, the final answer is going to be 4 plus 2 times whatever we got for the limit from g, and your final answer is going to be 6. Okay, so that is an example of using graphical techniques, using the graph of a function to answer a limit question.